Okay, in this video tutorial I'm going to go over another type of reaction. This one's called a double displacement reaction. So this is when the anions, the negative ions, and the cations, the positive ions of two different molecules switch places, forming two entirely different compounds. Basically with my analogy, I call this one the wife swap. So down the bottom here we start with, my example is potassium iodide and lead nitrate. So we've got a metal married to a non-metal, metal married to a non-metal, and basically they're going to swap wives. So potassium is going to get nitrate, be potassium nitrate, and lead, this metal, is going to get iodide, become lead iodide. Now you might be wondering what the 2 is. That's supposed to be a 2, like Roman numerals 2. Alright, just tells us that the lead here is the 2+ ion. So a few of our metals can make different ions. Now most elements only make a single ion, but a couple of our metals can make either a 2 or a 3+ ion, and I think lead is one of those. So anyway, let's have a look at this reaction. I've got a little clip of it. So guys, here we go. Some potassium iodide and lead nitrate. Both of these are colorless, clear liquids. So they look basically just like water. But when we combine them both in a test tube, or a boiling tube in this case, you'll see something quite interesting happens. So it's lead nitrate. I'll squirt some of that in there, and you can see a yellow colored substance forming. It's actually a solid. It's a powdery, kind of chalky-like substance. Forms when we add those two together. So we'll write the equation, and you'll see what's happening. But if we actually leave that to settle out, you can actually see, so I've got one here that I've left out previously. I'll just pull that one out. Here we go. You can see that the yellow stuff actually settles to the bottom as sort of a chalky, powdery solid. Okay? Alright, so let's write an equation for that. So, looking at your ion table, you've got potassium is K, and I'm going to use a couple of different colors. You'll see why in a minute. So potassium and iodine is I. Potassium is a 1+ ion, I is a 1-, so they match up perfectly, no problems there. Alright. Okay, and then we get lead, which is Pb, plum bum. Pb combines with NO3, nitrate, but Pb makes a 2+ ion. We know that because it said it was lead 2. Alright, sorry, NO3. And nitrate, NO3, only forms a 1- ion, so we'll need 2 of those. Again, if you can't do these, go watch my video on writing formula, so formula of compounds, and I've got one that's specific to balancing ions, and that's in the title too. So we're going to need 2 lots of nitrate there. Okay, so in this case, guys, we said it's basically the wife swap. A double displacement is basically a wife swap. So we get potassium is going to run away with, we've got potassium is going to run away with nitrate. So let's get our pen. KNO3. Now potassium is a 1+ ion, NO3 is a 1-, so that's no problem, that works. Okay, and that's going to run away with, so plus. Alright, so we've got potassium and nitrogen, and the other ones are going to swap partners, so this time lead is going to get the other one, iodine. So we've got our lead, Pb, running away with iodine. So it's just a wife swap or partner swap. We've just shuffled the couples around in the other combination. So lead iodide, lead is a 2+, iodine is a 1-, forms a 1- ion, so we'll need 2 I's. Okay, so we've got our basic equation there, we've got the formula for each substance, but we need to balance the equation. So let's start with the thing that looks the most complicated, and I'd say that's this one here looks the most complicated to me. It doesn't matter too much which one you start with, but we'll start with that one. Okay, so let's maybe use blue. So lead over here, I've got 1 lead, and over here I've got 1 lead. So they seem to be happy. We've got 1 lead on this side of the equation and 1 on that side. Now nitrate over here, I've got 2 nitrates. So 2 lots of nitrate, the whole thing in the bracket. And on this side, I've only got 1 nitrate. So let's put a 2 in front. And now I've got 2 lots of nitrate on this side. Cool, so that means now I've got 2 potassiums. 2 potassiums here. So come back to this side. How many potassiums on this side? Oh, I've only got 1. So let's put a 2 in front. Now I've got 2 potassiums on this side too. Okay, iodine, 2 lots of iodine. It's big 2, remember, 2 of everything. So 2 lots of iodine, 2 lots of iodine. And on this side, I2, oh, we've got 2 lots of iodine too. So let's run through and check that. 2 potassiums here, and 2 potassiums on this side. So those ones are happy. 2 lots of iodine on this side, I2, so 2 lots of iodine on that side. Iodines are happy. Lead, just 1 of them here. On this side, oh, just 1 of them there. 2 lots of nitrate, so the whole thing in the brackets times 2. Got 2 nitrates here. And yep, on this side, 2 lots of everything. The big 2 on the front tells us 2 lots of nitrate here. So everything's happy. That formula is balanced. Cool, so I hope that helped. And when you're looking at these, you're just looking for when you've got a partner, 2 things being added together that already consist of a metal and a non-metal. Both of them consist of a metal and non-metal. What's going to happen is they're just going to swap partners, and that's what we call a double displacement reaction. Okay, I hope that helped, guys.